Many of us are familiar with flexible spending account, also called FSA. It is basically a vehicle provided by the government to deduct your qualified spending without tax obligations. But the trick is you have to decide how much money to contribute before each year starts, and you cannot change after that. Moreover, if you do not use all of the specified amount, you lose it. So how do we figure out what's the best amount to contribute? Let's set up a simple model, and it'll capture the essence of such decision on the uncertainty. Okay, so first of all, let's set the marginal tax rate. Here, I assume it's 32%. It can be changed, of course. And our key decision is how much money to contribute. Highlight here. And for simplicity, we assume that in this year, the spending will be a uniformly distributed random variable between $1,000 to $10,000 that happens with equal probability. Now, for each of the 10 scenarios, you save a fixed amount, and that is the amount you contribute multiplied by your marginal tax rate. You do not pay tax on those for this amount, so that's a tax saving. In case you do not use all of it, there's an unused portion that you have to lose. On the other hand, though, if you need to spend more than your contribution, you need to spend more, and that's the basic trade-off. And our cost for each scenario is basically the total after-tax cost. So as you can see from here, this formula basically says my total contribution plus my additional spending, if at all, and minus my tax benefit. So column F is all the total after-tax cost. Now here is the formula for the total expected cost. Basically, it is weighted average of those 10 scenarios, and that's our objective. So how do we know which number will provide the lowest cost? We could set up a data table, and here are the 10 scenarios, and we use one-way data table. We will be able to calculate the total expected cost for each of the contributions, and it turns out that contributing $4,000 give us the lowest cost, total expected cost, as you can see from this curve here. Okay, now there's a second way which takes a little bit more time, and it lets you solver. If you go to data, solver, go to tools here, and we could set out the objective to be the total expected cost to minimize it by changing our decision variable up on top, which is B6. And here we set up constraints that it should be greater than 1 or less than $10,000. In fact, if you think carefully, there's no reason to select any quantity other than the 10 numbers here. So Excel ultimately will settle on one of those numbers. Now we're going to use evolutionary. Linear doesn't work anymore in this case, so evolutionary or nonlinear would be fine. Okay, so let's solve it. Notice that it will be quite some time, because essentially Excel will just go through many iterations, try to guess as to which is the right number. but eventually it will find that a number that is very close to 4,000 would be the lowest. So it will say that I cannot improve the current solution anymore. This probably is the best. But as you can see from here, it is trying very hard to start different initial values, and by compare many scenarios, hopefully it will come up with the right one. So we'll just wait a little bit longer to see. So you can see that it already tried around 4,000, and it is trying to see whether it can improve. So you can see that it is really close, and finally it says solver cannot improve the current solution, all constraints satisfied. Indeed, 4,000 is the lowest one. So that's how you solve this problem with uncertainty, either using scenario analysis or using solvers.